Hello everyone, this is Mr. G. I'm going to be explaining the sum and difference of two cubes. So we're going to be factoring the sum and difference of two cubes. Before we get into the formulas, let's look at some cubes. So here we have a picture of all kinds of different fruits cut up into little cubes. This one's my favorite right here, this purple cube. Let's look at cubing numbers. So if we take 1 times 1 times 1, we get 1. 2 times 2 times 2 is 8. Then 3 times 3, that gives us 9. Times 3 again, that gives us 27. That's how you go from left to right. You multiply that number by itself and by itself again, you'll get the number on the right. Let me do one more. If I do 4 times 4 times 4, that's 16. 16 times 4, 4 times 6, 24. 4 times 10, 40. 40 plus 24 gives me 64. So I hope you all understand how this table works from left to right, but it's even more important that you understand how we go from the right side to the left side, because to be able to use this formula, we're going to have to be able to go this way. So if you see the number 8, you have to realize that you can write 8 as 2 cubed, and that you can rewrite 27 as 3 cubed, and so on and so forth. You can write 1,000 as 10 cubed. So now let's go over the actual formula. So here are the two formulas we're going to be using for this section. The sum formula and the difference formula. Here's the sum formula, here's the difference formula, and they're written out like this. A cubed plus B cubed is equal to A plus B times A squared minus AB plus B squared. Few things to know here. The A is going to show up three times. It's going to be the first term in this binomial, the first term in this trinomial, and it's going to appear right here in the middle of the trinomial. Similarly for the B, it's right here. It's the second term of the binomial. It's in the middle term of the trinomial, and it's in the last term of this trinomial. The difference formula is very, very similar. All the A's and B's are in the same place as the formula above. The only difference is the signs. Here we have the same sign at the first position. Same thing for the difference formula. Plus plus, minus minus. Then we have always opposite. So for the sum formula, the opposite of a positive is negative. So we go from a positive to a negative. For the difference formula, the opposite of a negative is a positive. And then that last sign is always positive. Always positive. Whether it's the sum or the difference, it's always positive. So one way that you can remember this sign difference is with this acronym SOAP, which stands for same, opposite, always positive. You can remember the sign difference using this helpful acronym SOAP, which stands for same, opposite, always positive. Or in Spanish, los signos son igual, opuesto, siempre positivo. Okay, let's work through this first example, example 1a. We are asked to factor x cubed plus 27. As soon as you see that you're asked to factor something that's only two terms and one of them is cubed, you should immediately think Sum and difference of two cubes. In this case, it's sum of two cubes because of this plus right here in the center. First step is to rewrite this in terms of cubes. My x cubed is already written that way. This 27, what number times itself and times itself again will give me 27. 1 times 1 is 1, times 1 is 1, 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. So I can rewrite this as 3 cubed. You can also use the table we looked at earlier to try to figure out what's the cube root of this. The cube root is 3, so 3 cubed is 27. I'm gonna write my formula again. The sum of cubes formula, which is a cubed plus b cubed is equal to a plus b times a squared. I'm supposed to put the opposite sign, minus ab plus b squared. This sign is always positive, plus b squared. My a is going to be this x, and my b will be, let's see, let me get this color. My b will be 3. So I'm going to rewrite it like this. So a is supposed to be x, b is supposed to be 3, a is supposed to be x, and then the formula has an exponent 2, minus x times 3, plus, and then b is supposed to be 3 squared. 3 squared. I have to do one more step just to simplify. So I will get this binomial. Usually you won't need to simplify this at all. It's in the trinomial part, the second part, that we need to do some simplification usually. X times 3 is the same thing as 3x. So just rewriting the order and getting rid of these parentheses. And then the 3 squared, what's 3 squared? Please don't say 6. 3 squared is not 6. 3 squared is the same thing as 3 times 3, which is 9. Okay? So this is our final answer. The binomial x plus 3 times the trinomial x squared minus 3x plus 9. Okay, now let's look at example B, which has a cubed minus 125. Again, I have two terms. I see a cubed, so I'm going to be thinking about the difference of two cubes. I'm going to rewrite this first as a cubed minus 5 cubed. This one you can remember by looking at this units place digit 5. That's 125 ends in 5. It's going to be 5 cubed. I'm going to rewrite my formula of difference of cubes, which is a minus b times a squared plus ab plus b squared. In this case, my a is a and my b is going to be 5. So I'll just start plugging in. A is a, b is 5, a squared is a squared, plus, and I could write a5, but I'll just write it as 5a already. And then I could write 5 squared, but the simplified form of 5 squared is 25. So for these easy examples, you should be able to do them in about 2 quick steps. Let's take a look at example C. 8b cubed plus 27. So this part's easy. The 27, I can just rewrite that as 3 cubed. 3 cubed. This 8b cubed though, how can we break that up? So if you remember, 8 is the same thing as 2 cubed, and b, it's already written that way, so I can just rewrite it. And so I can actually factor the cube out in a way, and I can rewrite it as 2 times b quantity cubed. If you don't believe me, you can just rewrite this as 2b times 2b times 2b. I like to think of this as saying, hey, I have 3 copies of this expression. And here's my 3 copies written out. 2 times 2 is 4. 2 times 2 is 4. Times 2 is going to give me 8. And b times b times b will give me b cubed. So long story short, I can rewrite this expression as 2b quantity cubed plus 3 cubed. So now let me actually go through and solve that. I had 2b quantity cubed plus 3 cubed. Since it's a plus, I'm going to be doing the sum. So I'll write a, which is in this case 2b, plus b, which is 3. Notice my use of parentheses. That just helps me keep things straight. A is 2b squared minus 2b, oops, I'm going to run out of space, I think, times a, which is 3. And then plus b squared, which is 3 squared. So simplifying, we have a good amount of simplifying to do. I'll just get rid of the parentheses here. Then this 2b squared, if you want, you can rewrite it as 2b times 2b, which would give us 4b squared. And then this 2b times 3, 2 times 3 is 6. And then there's a b there, so it's negative 6b. And plus 3 squared is 9. So then that will be our final answer. Alright, now let's take a look at example D. It says 216c cubed minus 343d cubed. Wow, this one's a lot more difficult than the last 3 we looked at. So I think this D, I think it stands for difficult. But we can do it. We just have to take it one step at a time. If we look at this 216, one number times itself and times itself again will give us 216. I know it's going to be higher than 5 because 5 times 5 was 125, if you remember from the earlier example. So let's try 6. You can either punch it into a calculator, or you can work it out on paper. 6 times 6 is 36, and then times 6 again. We get 36. 6 times 3 is 18. 18 plus 3 is 21. So, yep, that works. So that's 6 cubed. All right, let me write it over here. 6 cubed. What about this 343? I know it's going to be higher than 6, so let's try 7. 7 times 7 times 7. What do we get? 7 times 7 is 49. And then times the 7 times this other 7, I'll get 7 times 9, 63. 7 times 4, 28. 28 plus 6, 34. Okay, so let me finish writing this. Minus 7 cubed d cubed. And just to be clear, what my a and b will be, it will be 6c quantity cubed minus 7d quantity cubed. Okay, so let me get myself some more space. That was 6c quantity cubed minus 7d quantity cubed. Let me write the expression this time, the formula this time. It's going to be a cubed minus b cubed is equal to a minus b, a squared plus ab plus b squared. My a is 6c minus 7d. I'm getting that from right here. This is a, this is b. Parentheses, a squared is, now for this problem, make sure you include parentheses when you're squaring things to make sure you square both terms. So it's going to be 6c squared plus ab. So I'll write 6c and then 7d plus b squared is 7d. So 7d quantity squared. That is equal to this binomial. Like always, I'm just pretty much just going to bring it down. And then here I have 6c squared, which means 6 times 6, which is 36. And then the c gets a square, plus 6 times 7, which is 42 cd. C times c is just going to be cd. And then plus 7 squared, that's 7 times 7. That's going to give me 49 d squared. So that will be our final answer for that one. Alright, let's look at example E. We have 16p cubed plus 16r cubed. So let me rewrite this in terms of cubes. So let's see, 16, well, we'll break down to 16. Let's see, can I try 2? Let's see, 2 times 2 times 2 will give me 4 times the other 2, that'll be 8. That doesn't work. How about 3 times 3 times 3? That would give me 9 times 3. That would give me 27. That doesn't work either. And if you look, 16 should be right in between these two. So what's going on here? What is going on here? Oh no. Oh no. I think I know what's going on. It's this. It's the GCF. I need to look to see if I can see a greatest common factor between my two terms. Now you could take out 2, you could take out 4, you could take out 8, but the greatest common factor in this problem is 16 itself. So you could rewrite that problem as 16 times p cubed plus r cubed. And then you could proceed with the rest of our problem. So let's do that. 16 times p cubed plus r cubed. So both of these are already in terms of cubes. I'm going to rewrite my formula. It's going to be the sum one, so it's going to be a plus b times a squared, the opposite, minus ab plus b squared. Now, before we forget, this formula gives us the factored form of this binomial. But there's also a 16 that we took out. That doesn't just disappear. We have to take that into account. So I'm just going to go ahead and bring it down now. I'll just write it there. And then as I rewrite it, I'll make sure to always include it. So my a is p, my b is r, then I'll get p squared minus p times r plus r squared. And since there's no numbers to simplify, this is actually my final answer. So I wrote down the problem again. Problem E, 16p cubed plus 16r cubed. Now I know if I tell you guys, hey, look for that GCF before you start the problem, I know most of you are going to forget eventually. So I came up with a little example to hopefully help remind you to look for what's called the GCF. And it's this, tofu soup. Tofu are these little white squares here. And the GCF is like a hair in your soup. Obviously, none of us wants to have a hair in our soup, so always look for that. And as soon as you see a GCF, whether it's this problem or lots of other kinds of math problems, go ahead and take out that GCF. Go ahead and take out that hair, and it'll make the problem a lot easier. Let's take a look at the last example, problem F, which states 3m cubed minus 81. How should we start this problem? Let's see. Oh, I know, we should look for that GCF, that hair in our soup. So what GCF is in this problem? It's going to be this number 3 here. So we can take a 3 out of both of these. We can divide by 3 and we'll get a 3 outside. And on the inside we will get m cubed minus 81 divided by 3 is 27. And I'm going to rewrite it one more time so that it is the same, so that both things are cubed. So I'm just going to write m cubed minus 3 cubed. The m will be my a, and the 3 will be b. So I'll write the 3 out in front, the one we factored out, and then I'll write m minus 3 a squared, so m squared, plus, so remember it's same opposite, then it's ab, so 3m minus, and I'm supposed to write b squared, so 3 squared, which is 9. That will be my final answer. So some of you might be wondering why I keep saying sum of two cubes or difference of two cubes. What I mean by cubes in cubic numbers. Well, if you looked at a cube and you labeled each side, let's say this length measured 5 and this width was also 5 because it's a cube, all of them have to be the same, and then this height was 5. How do I find the volume of a cube? Volume, that's given by the formula length times width times height, which in this case is, since it's a cube, all the numbers are the same, 5 times 5 times 5, which is 125. So that's why 125 is called a cubic number, and that's why 5 cubed is equal to 125. Today's video was made possible by Tofu Soup. Tofu Soup. which is the only food I could think of that always seems to have little cubes in it. So see this piece right here? That's a cube. Thank you guys for watching. Make sure you hit the like button, subscribe, turn on the notifications, share it with your friends. Make sure everyone watches this video. It really helps out the channel. Make sure you also look at the other video I made where I help you guys out with assignment number 5. Thank you all for watching. This has been Mr. G.